So we're beginning to learn about plate tectonics. You already know about continental drift, Alfred Wegener, and how he proposed that the continents move around. We have evidence of that from fossils, glacial striations, as you saw in the last video, that support the fact that there used to be supercontinents, and the continents that we have on Earth today have moved, although they move very, very slowly over long periods of time. Now, the theory of plate tectonics theory explains how that happens. And so we are going to start to look at plate tectonics and the interactions they have at their boundaries. The first thing I want you to notice is that we're going to work with a bunch of different images, different digital softwares, and even your worksheet is going to look a little bit different. There's a lot of different versions of the same thing. The plates are always the same, but there might be a little bit of a different artistic version. For example, this one. If you look very close, though, I have this one up here for a reason. Notice that when we think about plate tectonics, most students think that plate tectonics is the land. But the Earth's surface, there is oceanic crust and continental crust. So when we talk about these plates, the actual plate tectonics, the tectonic plates, they have both ocean and land on them. That's because under the ocean is land. That's oceanic crust. This is continental crust. There's just water on top of the oceanic crust. So when we look at something like the Nazca plate, you can see this plate is 100% made of oceanic crust. There's no land on it. There may be some tiny islands on there, but you can't see them in this picture. So this plate is mostly made of basalt, oceanic crust. The South American plate does have South America in it. The continental crust we call South America, the South American continent. But also that plate has a bunch of ocean on it, the oceanic crust. Some students think that the plates themselves are all dry land. It's not. It's just the surface of the Earth, and some of it is continental, some is oceanic. So this image looks the same. It's actually the same exact thing as this. So when we talk about the North American plate, this one here in this sort of purplish color, we're talking about all of the land that is above ocean, continental crust, and below ocean, oceanic crust in this area. As you can see, Canada is there, Greenland, right? We have America, Mexico. Also, the oceanic crust under the Atlantic Ocean is there. So get out of your head thinking that the plates are just the land. I mean, they are land, but it's not dry land. It's both dry land and the land under the ocean. All right? Now, when these plates interact, as you can see, there's arrows here. What you should take down in your notes is not only what I said a second ago, but also they can interact in different ways. Some plates are moving away from each other, as you can see here. Some are moving towards each other. Some are kind of sliding past each other. So there's three main types of what we call boundaries. Boundary is like the end of the plate, and depending on how the plate interacts with the plate next to it, we have different boundaries. Convergent means that the plates are pushing towards each other. Divergent means they're splitting apart, going away from each other. And transform means they're going across or sliding past each other. Converge, like connecting. Diverge, like dividing. Transform, like trans, meaning like go across. We're going to look at this deeper in this little topic in this subunit.